Hello guys, this is Ms. Michelle. Today we're going to learn a new topic which is formulas and nomenclature of ionic compounds. First of all, we're going to define what ionic compounds are. Ionic compounds are compounds composed of ions. We learned what an ion is during the first trimester of chemistry. What are ions? Ions are charged particles that form when an atom gains or loses electrons. There are two different types of ions: cations and anions. Cations are those that are positively charged, and anions are those that are negatively charged. When does an ion become more negatively or positively charged? When an atom gains electrons, this atom will become more negative. In this case, this atom will be an anion. On the other hand, when an atom loses electrons, this atom will become more positive. In this case, the atom will be a cation. Okay, there are some examples of cations in your periodic table. For example, group 1A, 2A, and 3A. In these groups, you will find elements that are cations. In group 1A, some of these elements are sodium, potassium, rubidium, caesium, and francium. In group 2A, there are found beryllium, magnesium, calcium, strontium, barium, and radium. What's the difference between the elements that are in group 1A and those that are in group 2A? Their charge. All the elements that are in group 1A, they have a charge of positive 1. Those elements that belong to the group 2A, they have a charge of positive 2. So, the elements that are in group 3A, such as boron, aluminum, gallium, indium, among others, all of these have a charge of 3 positive. Okay? On the other hand, we have some examples of anions. These are found in groups 5A, 6A, and 7A. The elements that are in the group 5A are nitrogen, phosphorus, arsenic, antimony, among others. Okay, all of these have a charge of 3 negative. The elements that are in group 6A, such as oxygen, sulfur, selenium, among others, all of these elements have a charge of 2 negative. And finally, the elements that are found in group 7A, which are also called halogens, all of these have a charge of negative 1. Some examples are fluorine, chlorine, bromine, and iodine. Let's continue. How can we write molecular formulas? Well, first, let's define what a molecular formula is. It consists of the chemical symbols for the elements followed by numeric subscripts describing the number of atoms of each element present in the molecule. So I chose this example of common salt. Okay, all the formulas are composed of a cation and an anion. All the ionic formulas are composed of a cation and an anion. For common salt is composed of sodium and chlorine. Okay, so sodium and chlorine, if we mix them, we will have what is sodium chloride. And in a few minutes, I'm gonna explain how do we get to this name. Okay, but here we have one molecule of sodium chloride, and in this molecule of sodium chloride, we can see the chemical symbols of the elements Na and Cl. Na is for sodium, Cl is for chlorine. And we don't have subscripts here because we only have one atom for each element. We have one atom of sodium and one atom of chlorine, and both they composed one molecule of sodium chloride. We have another example that is calcium and fluorine. When we mix the cation of calcium, which has a charge of 2 positive, with fluorine that has a charge of negative 1, we get what is calcium fluoride. So one molecule of calcium fluoride, we see the chemical symbols, okay, of calcium. The chemical symbol of calcium is Ca, the chemical symbol of fluorine is F, and also we can see the subscripts. For calcium, there's only one atom, so we don't have a subscript here. But for fluorine, we have two atoms of fluorine, and we can see the subscript of 2 that represents two atoms of fluorine in this molecule of calcium fluoride. So before we continue, we're going to learn the crossover rule. Cross over the charge on one ion to determine the subscript of the other ion and vice versa. So let's continue with the example of calcium and fluorine. As I mentioned before, calcium has a charge of 2 positive and fluorine has a charge of 1 negative. Okay, so we're going to cross over their charges, and now the charge of calcium will be the subscript of fluorine and the charge of fluorine will be the subscript of calcium. However, pay attention to this. We don't cross over the signs. We don't cross over the positive sign or the negative sign. Only their numbers. Okay? So now we have that 1 that was the charge of fluorine is the subscript of calcium, and 2 that was the charge of calcium is the subscript of fluorine. And as I mentioned before, this molecule is called calcium fluoride. Now I'm gonna mention some steps for writing the formulas. Step number 1, determine the charge on the cation and on the anion. Now I'm gonna use a different example, aluminum and oxygen. As we can see, aluminum is in group number 3, 3A, and has a charge of 3 positive. Oxygen has a charge of 2 negative. Oxygen is in the group 7A. Step number 2, crisscross the charges. We're going to crisscross the charges. Now the charge of aluminum will become the subscript of oxygen, and the charge of oxygen will become the subscript of aluminum. As we can see, the molecule of aluminum oxide, we have 2 atoms of aluminum and 3 atoms of oxygen. As you can see also, the charge of oxygen will become the subscript of aluminum, aluminum 2, and the charge of aluminum will become the subscript of oxygen, oxygen 3. Step number 3. Put the formula together by writing the cation first with its subscript, then the anion with its subscript. Step number 4. Make sure that the final formula has the smallest possible subscripts. For this step, I'm going to use a different example. Magnesium and oxygen. Magnesium is in group 2A and oxygen is in group 7A. Magnesium has a charge of 2 positive and oxygen has a charge of 2 negative. We're going to follow the same steps 1, 2, 3. So we're going to crisscross the charges, and we will get magnesium 2, oxygen 2. If the subscripts are both divisible by a common number, do this division, then rewrite the formula. What is a common number? In this case, well, the common number is 2. So we're going to divide both by 2, and we're going to write a formula. So the final formula for these cases will be like this. Magnesium, oxygen, magnesium oxide, without the 2 subscripts because both are divisible by the same number. Okay? Once that we learn how to write the formulas for the ionic compound, we're going to learn how to name them. So the first step is to name the cation. In this case will be aluminum. Step number 2. Name the anion by changing the last part of its element name. We have oxygen, so we're going to change the last part of oxygen for IDE. So it will be oxide. Step number 3. Write first the cation and then the anion. So If we want to name aluminum 2, oxygen 3, the name of this ionic compound will be aluminum oxide. Let's practice what we have learned. And for this, we're going to solve 3 different examples. The first step for writing the formulas of ionic compounds was to identify the anion and the cation. I already did this for you. In the left side, you can see 3 different cations: beryllium, boron, and magnesium. In the right side, you can see 3 different anions: fluorine, oxygen, and sulfur. Step number 2, we're going to crisscross their charges. Once that we have done this, now their charges will become their subscripts. So for beryllium, now beryllium has a subscript of 1, which was the charge of fluorine. Now fluorine has a subscript of 2, which was the charge of beryllium. The same for boron and oxygen. Boron has a subscript of 2, which was the charge of oxygen, and oxygen has a subscript of 3, which was the charge of boron. In the third example, both have a charge of 2, magnesium and sulfur. So both will have a subscript of 2. What will happen here? Both are divisible by the same number, so their final formula will be magnesium without the 2 and sulfur without the 2. Now we're going to name these 3 different ionic compounds. The first step for naming ionic compounds was to name the cations. For the first example, we have beryllium. For the second example, we have boron, and the third example, we have magnesium. The second step is that we're going to change the last part of the name of the elements. Okay, for example, fluorine, we're going to change the I and E for IDE. So instead of being fluorine, will be fluoride. The same for oxygen, will be oxide. And the same for sulfur. Instead of sulfur, will be sulfide. So these are their names: beryllium fluoride, boron oxide, and magnesium sulfide. Okay guys, so we have come to the end of this video. We're going to continue doing more exercises about this topic so we can become experts on it. Hopefully you have liked this video. If you missed something, you can watch this video again. I'm going to upload more exercises, so please get into your classroom of chemistry, okay? Thank you guys. Bye-bye.